How to be a mathematician? What kind of skills are needed to become a mathematician? First, you need to be able to recognize patterns and then find relations among different patterns and explain why. Why does it work? Or formally, you assert a statement that something is true, then you give proof why it is true. Let's start with some simple patterns. The whole numbers, the natural number sequence or counting sequence is 1, 2, 3, 4, 5 and so on. Then we also know odd numbers 1, 3, 5, 7, 9 and so on. Even number sequence 2, 4, 6, 8 and so on. Square numbers, number multiplied by itself. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16 and so on. We also know cube numbers. Number multiplied by itself 3 times, 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27 and so on. Then we find relations among different patterns. So odd numbers is related to the square numbers, because if we do the sum of the first n odd numbers, the first two odd numbers, the sum is 4, which is 2 squared. The first three odd numbers, 1 plus 3 plus 5, is 9, which is 3 squared. The first four odd numbers, 1 plus 3 plus 5 plus 7, is 4 squared, which is 16. So the sum of the first n odd numbers is equal to n squared. How do we explain that this is true? And furthermore, that it's true for all n natural numbers. So there are several ways you can visualize, give some visual proof. So this is 1, which is 1 square. And if you want to make a square with the side of 2, which is 2 square, then you need 3. So 1 plus 3 is 2 square. If you want to make a square with a side of 3, then you need 1, 2, 3, 4, 5, which is the next odd number, and so on. So this is a visual explanation of why it works. More formally, you can also give proof. This is called the induction. You prove that it's true for n equals to 1. Then for any n, Pn is true implies Pn plus 1 is true. So if this is true for 1, n equals 1, then it's true for n equals 2, is true for n equals 3, and so on. So it's true for all n. So if we can show this, then we're done. Okay, let's start n equals to 1. So it's obviously true. Then we need to show that this relation is true for n. Does it imply that it's also true for n plus 1? Let's see, we add the next odd numbers. The next odd number is n plus 1 on both sides. See if this can reduce to the same kind of relation. So it shows that Pn is true for n, implies that it's also true for n plus 1. So our proof is done. We start with the statement. We say that this statement is true for all n. We show that by saying starting with n equals 1, then Pn implies Pn plus 1, then it must be true for all n. So we're done. At the end of the proof, we might write like this, or we can write QED, quod erat demonstratum. That's it. You are able to recognize patterns, you're able to find relations among patterns, and you're able to explain why. Congratulations, you are now officially a mathematician.